in the book exercise, under the topic electromagnetic induction, the first question: predict the direction of induced current in the situation described in the following pages. Okay. So this is the diagram. We are supposed to predict the direction. Now look at the first one. You've got a solenoid coil. It is not. So in this coil, that is P, Q, and R is there. Then you have got this S, N. That is, this represents the Bohr magnet. So the Bohr magnet now it approaches inside the coil. Okay. So what we are supposed to do, we have to apply the Lenz law. Take down. So in the first case, diagram A, you can draw this diagram. And this is the coil. Now the Bohr magnet is inserted inside the coil. So we can apply the Lenz law. Why? Because the induced current, take down, the induced current will flow to oppose the magnet. So if it flows to oppose the magnet, so when it oppose means there is some kind of repulsion. So what kind of pole should be established here? South pole is established. So when you make a solenoid like this and the current is passed through this means it acts as another ball magnet. You know very well when you have kept another let me consider we have got two Bohr magnets, north pole and it is the south pole. This is north pole. Now if it is opposite pole, they will attract each other. But this is south pole and it will repel according to what? That is Lenz law, and that is why we put the minus signs. Okay. So on applying, take down, on applying the Lenz law, the induced current will flow to oppose the magnet. To oppose the magnet. And if it is south pole, and definitely south pole is developed at Q, at the end Q. Okay. Therefore, the current should be in this direction. What? That is Q and then P or Q. Okay. So the correct answer is the current will be flowing in this way. You can put the direction. So what is the direction now? Q, P, R, again Q. Okay. So the direction is Q, P, R, Q. So what is the concept here? Lenz law. Why? We have to put the negative sign there. So it opposes the magnet. That is why it develops a south pole here and north pole here. Got it? And let us move to the second one. So here also you got the coil and the south pole is here. It is moving in this way. And you have got another coil. Okay. So where the terminals are X and Y. In this case, P and Q. So it means there are two coils here. So the south pole developed at Q. We already discussed there is a south pole developed. Okay. So in that case, how about the current direction here? That is the south pole is development. It is in this way. So it means that is P and then what? Tell me P, how it goes? It is developed. So what is the direction here? The first case. We have got two coils. No, it has to go like this one. So P R. So since it is here, we call it that is a Q P R Q. So in this case, P R Q P. Okay, take down. So the first one is P R Q P, and the second and how about the second one? That is here. It is in the same way. Okay, so it means Y X Z Y. Okay, so here Y X Z, Y. In this case, P, R, Q, P. P, R, Q, P. Got it? Draw. And the third one. So here you got the common axis and you have one loop here and another loop that is connected to the power. That is some circuit. So here the tap key is just closed so that the current will be flowing like this. So if it is flowing, and what about this direction? It will be in the, that is y z x direction. Okay, that is y z x, y z x direction. That is from y. So this is moving in this way. So this is opposite. Okay, are you able to follow? Draw. Similarly, you have XYZ coil and you have another coil connected to the circuit where it is connected to the rheostat. What is the purpose of rheostat? You can change the resistance and by change the current also. Okay. So in that case, it is, for example, that is, it is flowing in this way. Okay. So what about X, Y, Z? So here also, that is, uh, that is Z, and then, so this is going here. So here it will be. Okay. So mark the direction like this. So Z, Y, X. It is opposite. Okay. Z, Y, X. So if it goes like this means here it is in the opposite direction. Now here it goes means it is going here in this way. Okay. So Z, Y, here. Now what is the next one? Now you've got two solenoids. That is one is connected to the circuit, another is kept nearby the coil. Okay. Now we have to indicate the current direction in E. So in that case, for example, minus 2 plus means plus 2 minus. So it goes like this. Okay, take down. I'm sorry, that is plus 2 minus. Can you get my eraser? It will be like this. So electrons are moving from cathode to anode. It means from anode to cathode, current is moving. Okay, this is anode. So anode to cathode. Okay. So then in that case, what about the direction of current here induced? It is opposite. Okay. So if it goes like this means X, R, Y. Okay. Induced here north pole when current is flowing before release of the tapping key. Just okay. Then the key is induced flux opposite. So this decrease in the favor of increase in the flux. Okay. So there is an increase in the flux because the current is moving and it induces here. where in the nearby coil. The nearby coil is not powered. The primary coil is powered, whereas secondary coil is not powered. Okay, so it means that it is induced here. So it means again here that is it will move in this direction. That is X or Y only. Okay, you can mention this as X or Y. That is from left to right. Then what about this steady state current? That is current decreasing at a steady state. For example, that is it is moving in this way. And what about this loop? So here, what is the case of F? Now the current decreases in straight conductor. Okay. So there is no, I mean, a flux change. So no flux change means, and no current change also, no current also. So it means no current is induced here. Current induced.